Students, from today we will start the physical property of alcohol. We have finished the preparation of alcohol. Now we go to the physical property of alcohol. In physical property of alcohol, students, first we will see physical state. Do remember at ordinary temperature, lower members are colorless liquid. Means lower alcohols like methyl alcohol, ethyl alcohol, they are lower members. So methyl and ethyl are lower members. They are colorless liquids having a characteristic smell. Okay, they have a characteristic smell where at burning taste. They have characteristic smell and burning taste. But the higher members having more than 12 carbons means methyl has one carbon, ethyl has two carbon. They are lower members. They are colorless, having some tastes and burning taste. But the higher members, which is above 12 carbon, they are colorless, odorless, and wax like solid. They are wax like solid, students. So do remember the physical state. Lower members are colorless liquid, but they have some smell and burning taste. Higher members above 12 carbon, they are colorless. They don't have any taste, and they are waxy liquid. Now the boiling point. Do remember boiling point of alcohol is much more higher than the corresponding aliphatic hydrocarbons and even haloalkane. That means boiling point of alcohol is more than haloalkanes and alkane. Why? Now let us see the reason for it. You can see boiling point of alkane is methane is one of the example of alkane is 90 Kelvin. Methyl chloride is haloalkane, it's 249 Kelvin, and methyl bromide is also haloalkane, it's 298 Kelvin. Whereas for methyl alcohol is 337.5 Kelvin. So if you see this point is haloalkane, boiling point is 90 Kelvin for methane. For haloalkanes like methyl chloride and methyl bromide, it's 249 and 278 Kelvin, whereas for alcohol is 37.5 Kelvin. So if you compare here, so students, if you compare here, the boiling point of alcohol is much more higher than haloalkanes as well as aliphatic hydrocarbon. Why the boiling point of alcohol is more than haloalkane and alkane? It's because that all alcohol shows intermolecular hydrogen bond. Okay, all alcohol shows intermolecular hydrogen bond. It has been taught in class 11 as well as in under the chapter called chemical bonding, even in P block element. So alcohol shows intermolecular hydrogen bonding. So this is one alcohol. R can be methyl ethyl, ROH, ROH, ROH. You can see the three molecules of alcohol are here, ROH, ROH, ROH. And H and O are linked by this dotted bond represented by the hydrogen bond, intermolecular hydrogen bond. Again, H and O of two different alcohol are linked by again dotted bond, that is hydrogen bond, and the chain continues both sides. Since alcohol shows intermolecular hydrogen bonding, that's why they have high melting point and boiling point. MP means melting point, BP means boiling point. So methane, which is an alkane, methyl chloride, ethyl chloride, which is haloalkane, they don't show intermolecular hydrogen bonding like alcohol. So that's why they have low melting point, boiling point as compared to alcohol. But alcohol has higher because of intermolecular hydrogen bond, which you can see here. Not only that, since alcohol shows intermolecular hydrogen bond, therefore their molecular weight will be more, molecular mass will be more, because one molecule connects with another molecule, so the molecular mass is more. Therefore they are liquid, they are non-volatile. Okay, they have high melting point, boiling point, they are miscible in water. These are the four things happens if a compound shows intermolecular hydrogen bond. So with respect to haloalkane and alkane, alcohol shows intermolecular hydrogen bond, because of which they are liquid, they are non-volatile, they have high melting point, boiling point, they are miscible in water. So all alcohols are liquid because they show intermolecular hydrogen bond. They are non-volatile because they show intermolecular hydrogen bond. They have high melting point, boiling point because they show intermolecular hydrogen bonding. They are miscible in water because they show intermolecular hydrogen bonding, students. And this is all about boiling point. So whose boiling point is more? You have to remember now. Alcohol, why? Because they show intermolecular hydrogen bonding, whereby their molecular mass increases, so they have high melting point, boiling point. Whereas alkane and haloalkane does not show intermolecular hydrogen bonding, so their boiling point is comparatively less than that of alcohol, students. Not only that, even ether does not show intermolecular hydrogen bonding. Therefore its boiling point is less than that of alcohol. So ethyl alcohol and methyl alcohol, dimethyl ether, their molecular mass is same. Ethyl alcohol molecular mass is 46, and that of dimethyl ether is also 46. You can see here its molecular weight is 46. So molecular mass is same, but in that case ethyl alcohol shows intermolecular hydrogen bonding, whereby it is non-volatile. It does not show, that's why it is volatile. So dimethyl ether does not show intermolecular hydrogen bonding, so it's volatile. It shows it is non-volatile. It is liquid, it is gas. It has high melting point, boiling point, it has low melting point, boiling point. It is miscible in water, it is not miscible in water. Why? Because this shows intermolecular hydrogen bonding, this does not. So to remember, one question has come from here, students, somewhat like this. Ether, in general, the question has been asked, ether, okay, are volatile than alcohol, though they have same molecular mass. You can see here 46, 46, molecular mass is same. So this is more volatile than this. It was given in assertion. Assertion was ether is more volatile than alcohol, though they have same molecular mass. That was assertion. Reason for that was alcohol shows intermolecular hydrogen bonding. And there was 4 option. And for this answer will be D. Means assertion is correct because it is volatile than this, correct. Reasoning is also correct because this shows intermolecular hydrogen bonding, that's why it is less volatile, it is more volatile. So here the answer will be D, where you have to say assertion is true even your reasoning is true, and the reasoning is the correct answer for the explanation of the assertion. So D will be the correct answer for that, students. So I have posted you that question in front of your screen. You can see that, and to remember the answer for that is D. This question has been asked from your physical properties. So far we have finished 2 physical properties, students. One is boiling point, the other is physical state. So to remember, now we go to the next property of it. The next property of it is solubility. Do remember, students, alcohols are highly soluble in water as compared to ether. Why? Because alcohol forms intermolecular hydrogen bonding with water. That's why it is soluble in water. Whereas ether does not form intermolecular hydrogen bonding with water. That's why it is immiscible or insoluble in water, we say, students. So always remember, alcohol are soluble or miscible in water because they form intermolecular hydrogen bonding with water. Whereas ether, they don't form intermolecular hydrogen bonding with water. That's why they are insoluble. You can see out here. You can see there is one alcohol molecule here, ROH is alcohol, and this is your water, this is your water. And between alcohol, ROH, and water, you can see the dotted bond form. This is called hydrogen bond, intermolecular hydrogen bond. So alcohol forms intermolecular hydrogen bond with water, with water, with water. That's why it is soluble in water. But who does not form like this? Ether. So therefore it is insoluble in water, students. Okay. So yeah, also we'll see, students, one interesting question related to boiling point of alcohol. As you know, boiling point of alcohol is higher than that of haloalkanes and alkene due to intermolecular hydrogen bonding shown by alcohol, and alcohol boiling point is much more higher than ether also because of intermolecular hydrogen bonding. But these are the 2 important points regarding boiling point to be remembered for objective questions, which I'll discuss later. Boiling point of alcohol increases with increase in carbon chain due to increase in surface area and increase in van der Waals force. Now let us see what is that. CH3 means methyl. If we add CH2, it becomes ethyl. Again, if we add CH2, it becomes propyl. Again, if we add CH2, it becomes butyl. So CH3 means methyl, CH3 CH2 means ethyl, CH3 CH2 CH2 means propyl, 3 carbon. CH3 CH2 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 means 4 carbons, it's butyl. Now if you put OH, 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 OH in all, it becomes methyl alcohol, ethyl alcohol, propyl alcohol, and butyl alcohol. And if you see here, OH is linked with CH2, so it's primary alcohol. OH is linked with CH2, it's primary alcohol. OH is linked with CH2, it's primary alcohol. But in methyl alcohol, OH is linked with CH3, but yet it comes under primary alcohol, students. So these are the examples of primary alcohol, students. All 3 are examples of, all 4 are examples of primary alcohol because OH is linked with CH2. Here it is not linked with CH2, but it is linked with CH3, but yet it comes under primary. Now if you see, the carbon chain is increasing in linear form. So as the carbon chain increases in linear form, students, do remember surface area will also increase. When the carbon chain increases in linear form, surface area will increase, And if the surface area will increase, van der Waals force will also increase. Therefore, longer the chain, more the boiling point. So butyl alcohol will have more boiling point than propyl. Propyl will have more boiling point than ethyl. Ethyl will have more boiling point than methyl, and this is the increasing order of boiling point. From methyl to butyl, this is the increasing order of boiling point. You can repeat the video if you don't understand in one go. Now we go to the next one. Boiling point of alcohol decreases with increase in branching of carbon chain. Now you can see here CH3, CH2, CH2, CH2 means butyl. Methyl, ethyl, propyl, butyl. So this is butyl. Now here CH3 I have kept as it is, CH2 I have kept as it is. Now here what I have done, I have taken this one H out here to make it CH3, which is up. Then what remains here is CH. And this is called isobutyl. This is butyl, this is called isobutyl. Now here what I have done is we have kept C in the middle, then CH3, CH2, CH3. There are 4 carbon again, so we call T-butyl. So this is called butyl, this is called isobutyl, this is called T-butyl. If I put here OH, it becomes your T-butyl alcohol. If I put here OH, it becomes isobutyl alcohol. If I put here OH, it becomes T-butyl alcohol. So all of them are alcohol. Now if you see and compare out here nicely, students, what you observe, OH is linked with CH. So OH linked with CH is tertiary alcohol. That's why T stands for tertiary. Here OH is linked with CH, so it's secondary alcohol. And here OH is linked with CH2, is a primary alcohol. Okay, so OH linked with CH is tertiary alcohol. OH linked with CH is secondary. OH linked with CH2 is primary. Now if you see, here is also 4 carbon, here is also 4 carbon, here is also 4 carbon. Carbon chain is same, but it is increasing in branching form. Here it is linear, it is branch, here is totally branch. So as the carbon chain increases in branching form, students, do remember surface area will decrease. You can assume this way. The 4 bricks you are keeping in the linear form, 4 bricks, 3 in one row, 1 above. And here all the 4 bricks are like this. So here you can see which will occupy more area, obviously this. So more the surface area, more the van der Waals force, more the boiling point. Here, due to branching of carbon chain, surface area decreases and van der Waals force will also decrease, so it will have lower boiling point. So do remember here, T-butyl alcohol will have more boiling point than isobutyl alcohol, and isobutyl alcohol will have more boiling point than T-butyl alcohol. And this is the decreasing order of boiling point. So from here we can conclude like this, students, saying that primary will have higher boiling point than secondary, secondary will have higher boiling point than tertiary. The conclusion is here. Tertiary alcohol means 3-degree alcohol will have the least boiling point due to small surface area. Van der Waals force will be less due to branching of carbon chain, so it will have lower boiling point. More than that is of secondary, and more than that is of primary. But in primary there are so many primary alcohol which will have higher boiling point, the one whose chain is longer. You can see from here, students, all of them are primary alcohol, but these primary alcohol have longer chain, so it will have higher boiling point, students. So the conclusion is like this, students. Always remember tertiary have the least boiling point, more than that is of secondary, more than that is of primary due to more surface area, more van der Waals force, more boiling point. Due to less surface area, less van der Waals force due to branching, so lower boiling point. But in primary, who will have the will have the higher boiling point? The one whose carbon chain is longer. Now related to this, let us see some MCQ question. Okay, the first one. Among the following, which has lower boiling point? It is given here. So from this conclusion, you can make it. Primary, secondary, tertiary, none of this. Who will have lower boiling point? So the answer is tertiary butyl, because tertiary will have lower boiling point. Now here, who will have lower boiling point? So first you need to isolate which alcohols they are. Do remember, isopropyl is a secondary alcohol, T-butyl is a tertiary alcohol, whereas ethyl and propyl are primary alcohol. Now the question is saying which will have lower boiling point. So in this, tertiary will have lower boiling point, so answer is T-butyl alcohol. But in the same question, if I have asked you which will have higher boiling point, which will have higher boiling point, then it will be primary. Primary will have higher boiling point, but there are 2 primary here. If I ask you which will have higher boiling point, then there are 2 primary alcohols, and primary has the higher. But which will have higher, methyl or propyl? Ethyl or propyl? Ethyl has 2 carbon, propyl has 3, whose carbon chain is longer. So the answer would have been B that time. Okay. Now here, methyl, ethyl, propyl, sec propyl, which will have lower boiling point. So methyl alcohol is a primary alcohol, ethyl is primary, propyl is primary, and isopropyl is sec propyl, and isopropyl means same, and that is secondary alcohol. So which will have lower boiling point? Tertiary, but there is no tertiary here. After that, secondary. So the answer will be sec propyl alcohol. In the same question, if I have asked you which will have higher boiling point here, higher, then obviously primary. But there are three primary. Which primary? The one whose chain is longer, methyl ethyl propyl. So propyl will have longer chain. So answer would have been C. So hope so you all understood how to go with these questions under the topic called boiling point. So do not forget this. It's very important for MCQ question students. You can take the screenshot to make the notes. Thank you very much.